Hello, good morning. Okay, good morning, Iru. Okay, hopefully the all student is here. Okay, today I want to continue the lesson. There's a transistor, there's a section number 2. Okay, you all can be listen or not? Okay, can listen my voice and also you can see me or not. So if okay, I just go on. Okay, can. Thank you, Iru. So the rest, hopefully you watching now, watching the YouTube now. Okay, I want to complete this one topic today. So from here, I will go through. So you just follow. Okay, so I change the layer first. Okay, so we go through to the next part. Okay, let's see the transistor. Before that, we learn about transistor, how to function, the structure in the transistor, how about the base, how about the current in the collector circuit. So that one is current, how to flow. Okay, now, after we know the how to move about the current and electron, so that means now we need to see about the applications. Okay, application for the transistor actually got two only. One is an amplifier. Okay, transistor can become amplifier. Another one, there should be the automatic switch. Okay, so we see how the application now. Okay, first one, a transistor can magnify the electric current. So that means you provide a little bit current, then later the output they can magnify. Okay, can make the current become increasing more. So they become the voice of the signal can be amplified by using the amplifier system. So the amplifier system inside, they sure got the transistor. Okay, good morning, Khatija. Okay, so we continue. A transistor, they function also as a switch. Okay, in the transistor circuit, the current does not flow in the collector circuit. Okay, remember, when I just put the transistor, if you don't have any base, actually the collector cannot function. So from there, they say transistor circuit current in the collector is memang cannot function. So they must depend on the base circuit. Okay, they must depend on the current in the base circuit. So from here, we call it transistor can function as a switch. So this one switch is based on to the base current. Okay, using the base current to switch on the collector current. So from here, this one is a two application for the transistor. Okay, now we're going to see one of the activity 5.8 from your textbook. They want to study about the transistor as a current amplifier. So transistor kit, they're using the transistor kit and also different resistor. So they're using 2.2 until 8.2. So after that, the ammeter, they're just using the milliammeter, okay, for 0 until 1 milliampere. Okay, 100 to 0 to 100 milliampere. This one is a bigger ampere, is it? So this one is normally we connect with the collector circuit, because collector circuit later they produce a bigger current. Okay, 6-volt power supply and 1.5 the dry cell and the holder and connecting wire. Okay, let's see the procedure. Okay, and also the diagram. Okay, first one, the reading of the A1. A1 is a resistor 1. They put about a 2.2 kilo ohm resistor. Okay, after that, A2 as a current collector is recorded in a table form. So that means later we need to find out the reading of the IB and also IC. So we go to adjust is a resistor. Okay, if you keep increase the resistor ohm, that means understood lah, V equal IR, I and R is inversely proportional. If I keep increasing the resistance, so that means later the current will be dropped lah. Agree, yeah? So the IB will be dropped later when I keep increasing the resistor. So the IC also follow. They also follow the IB. If IB drop, IC also will drop. Okay, but they drop less. Okay, they drop about less. When the IB increase, the IC will increase more and more, because they become the amplifier, is it? So we see the result. Okay, the result like this. Okay, we got 2.2 until 8.2. So I keep increasing the resistor, so the current will drop. Now we see the answer. Okay, IB from the 0.6 drop until 0.13. Okay, when 0.6 is the maximum, is the highest one. So that means when 0.6 for IB, okay, what happened for IC? IC is amplified. So the IC must be more and more. Okay, now we're going to see the result. Okay, they become 94. Okay, so that means I just apply a little bit base current. You see the collector current, they will bigger so much. So this one become one of the function of the transistor. There's an amplifier. Okay, so we go through to the next discussion. You need to plot a graph. Okay, now the graph is a IC versus IB. So after you plot the graph, you need to determine the gradient of the graph. Okay, after that, you need to calculate the current of the amplification factor of the amplifier. So we need to find out this one current amplification already how many times they need to increase it. Okay, so from here, there's a beta lah, the symbol for it, there's a beta. So we do the graph first. Okay, this one is a formula if you want to find the current amplification factor. So IC must over the IB. Okay, now we're going to see the graph first. Okay, this one is a graph. You need to plot the graph is a IC versus IB. So IB is at the bottom lah. IB is a axis X. Yeah, correct. IC is a axis Y, then the IB is a axis X. So I put 20. You see when you plot the graph, make sure there's a consistent. 20, 40, 60, 80, then 100. We start from 0, then 0.1 until 0.6. Okay, then all the point we transfer in. Okay, we transfer all the point in. After that, we plot. Okay, there's a one straight line pass through the origin. So we can say this one is a directly proportional. IC and IB, there's a directly proportional. Okay, now the question, we want to find gradient. Okay, gradient, normally you want to draw a triangle. Okay, triangle, we draw the bigger size one. Better is a bigger size, don't draw the small size. So we draw the last one. That one should be the bigger size. Okay, I take this one as a triangle for gradient. So the gradient formula, everybody know, y1 minus y2 over x1 minus x2. Remember, must y over x. Okay, so y1 minus y2, so this one should be the 90 something, is it? So from the table, I get 94. Okay, 94 minus 0, then the x is a 0.6, 0.6 minus 0. So from here, I get it, 156.67. Okay, that's a no unit because you're using the IB and also IC. Both also is an ampere, milliampere. So milliampere over milliampere, that's a no unit. Okay, so from here, the question, they say they want to find the current amplification factor, is it? That's a beta. So from here, the beta formula actually is IC over IB. So the same as a gradient. So from here, the beta, there's a gradient. I no need to do another calculation already. I straightforward to copy the answer. So from here, I can just mention the beta is how many? 156.67. No unit. Okay, because the current amplification factor same like the gradient. Conclusion, a small increase in the base current, the result in a big increase in the collector current. So they just want to prove, is it transistor, the function is amplifier or not? So they go to test. I just a little bit changes for the base. Then what happened for the collector? So they find it, the collector, the current increase more and more. So that means after the current pass through transistor, then they can amplify the output current. So now we can say transistor is a one amplifier. Okay, so from here, base current flow, if IB is a 0, so you no need to think about the IC can function. No IB, sure is no IC. So the gradient of the graph is an amplification factor. Okay, this was one of the graph to show you. 78 is an IC, then the IB is a 0.5. So if the question they want to find about the amplification factor, means they need to find gradient. Okay, remember when I just say I want to find amplification factor, so understood IC over IB. So if the graph is IC versus IB, then you find gradient. If the graph terbalik, IB versus IC, so you need to find 1 over gradient. Depends the graph, but the formula is fixed already. The formula must be IC over IB. So from here, we just show gradient of the graph. Okay, M equal 78 minus 0 over 0 0.5. So I get the answer 156. Okay, so from here, I can mention, okay, actually your amplification factor, there's a beta equal 156 because they're equal to the gradient. So this means what? The change of the 1 milliampere in the base current, that will cause 156 milliampere in the collector current. So if you get 156, mean you bigger, the time is a 156 times. So if I say the base is a 1 milliampere, means your collector circuit is a 56 milliampere. Okay, that means you do this one calculation, actually you want to find it that how many times is bigger. Okay, so we continue to the next part. Small increase of base current that will cause a big changes for the collector current. So from here, transistor can function as a current amplifier. Okay, so who is that? There's a Karungaran Jonathan. Okay, so morning. Okay, so from here we go to describe how the transistor can become the automatic switch. Just now is a amplifier. Now I want to mention about automatic switch. Okay, we go to see how the transistor function. Okay, this one you need to focus is a voltage, base voltage, and also the battery voltage. Okay, remember this part is a battery. Then you got R1 and R2. Suppose this one is a voltage divider. Okay, divider means they need to separate to R1 and R2 lah. So from here, important is a V out. This one is depend for the output. They want to connect it to the transistor. So important is how to make transistor on. The base circuit must on lah. Must have base circuit, then the transistor can function, is it? So from here, we need to see how to make base circuit on. Okay, I want to make the base circuit got current. How to make it? Okay, let's see here. In the working circuit, a resistor 1, okay, R1, this one, and a series R2. So R1 and R2 is series. So after that, they're being used from a potential divider. R1, R2, they will divide the potential difference. Okay, then we go to base voltage. This one we call base voltage. VBE, base and also emitter. So this one base voltage. Okay, if I say IB 0, then IC understood 0. So how about the transistor? Off. Transistor cannot function because no current. Okay, now we go to second situation. If the variable R2 is set to low, the base voltage is low. Okay, if I set this one R2, okay, this one R2, if I put very, very low resistance, then how about the V? Okay, because current constant, because series, V equal IR. When the I become constant, then I make the resistance become very low. What happened for the voltage? The voltage is understood also low because V and R directly proportional. Okay, when the current constant. So from here, the R2 is set become low, base voltage also low. Then the transistor switch off because don't have any current. Because voltage is a low, then no base current, then the transistor off. So the base current does not flow and also collector also cannot. So that means important is what? Important, you need to create the voltage output. You must have the voltage here. Then after that, everything can be function. If no voltage, actually nothing. Okay, transistor cannot function. One. Okay, now we go to increase the voltage. However, if the resistor variable R2, I go to increase. Now you see, base voltage will increase. Okay, when you got base voltage, understood, you got base current. Okay, base current just go, then they will switch on transistor. When I switch on transistor, then you must think back lah. Before that, we learn about the electron, how to move. Then after that, they go to jump. After that, they produce a collector current. Finally, the bulb can be light up. So from here, we continue. When the base voltage just exceed the junction voltage, remember PN junction, you need to over the PN junction, baru can function, is it? So that means when I just provide the voltage, so the voltage sure more than PN junction, because PN junction very small only 0.6, 0.7 or 0.1 volt only. When you just apply one battery, already is 1.5. So your connection must be correct lah. Connection is wrong, that means 0. So when the base voltage just exceed the junction voltage, so base current, now they start to flow and cause a large collector current flow and switch on transistor. So finally, the bulb can be light up. Okay? So from here, you can find out one of the things I totally never mentioned. There's a R1. R1 is not related. Important is R2. Okay? Sometimes the R1 we use what? We use to control the resistor. Okay? R1 they can using the variable one. When I just control my resistor becomes smaller, then the rest one will be bigger. So normally it's R2 that's important. When you create the R2 bigger, automatically inside the voltage will become increasing. Okay, now after we understand how about the R2 and also the voltage function, then we need to go through actual situation. That means the automatic switch. Okay, the last one, the transistor is off when the VBE is small, and then will on when the voltage base emitter is large. So important is a base lah. Okay, now we go to answer some of the question first. What is the condition of the base voltage to switch on the transistor? Okay, what condition you can switch on transistor? You must have the high base voltage. Okay, you must have the high base voltage, then can switch on the transistor. So the answer is base voltage must be over junction voltage. So they got high base voltage lah. Your over junction voltage, that means no problem. You can switch on transistor. Okay, state the minimum junction voltage. Okay, minimum junction voltage is separate by 2, silicon and also germanium. So we just label silicon is 0.7 volt. Okay, germanium is 0.1 volt. So that means when you just over this one junction voltage, actually there's no problem. You can switch on the transistor. Okay, formula to calculate the minimum base voltage, VBE, to switch on the transistor using potential divider. So remember the potential divider, you want to find the V1, then you want to find the V2, then we got formula. That's easier for you to do the calculation when the question never provided current. Okay, never provided current. Okay, I never mentioned say you cannot using current. You can. You also can using the current to do the calculation. But there will more method lah. You more step to do the calculation. So if want to fast, so we can using voltage divider formula. Okay, there's a V output. V output normally we mention there's a V2. Okay, V2 equal R2. When V2 up must be R2 over R1 plus R2, then multiply the V input. V input is a total voltage. Okay, so this one is a formula when you want to calculate the output potential difference. Okay, so now we're going to see the first function for the transistor. There can be the switch. What switch? Light dependent resistor. Okay, that means they control the light. Okay, this one we apply for the street lamp. Okay, at the night you see the street lamp, suddenly they on together. This one, that means they're using the transistor. Okay, using the transistors to switch on the street lamp. So normally how they go to switch on? They detect the light intensity. So that means during the day, that means you got light, is it? You got sunlight, is it? So the light in the street lamp, they will automatically switch off. Okay, during the night, maybe 7 o'clock, you find the sky become dark already. So they start to switch on. So that means they detect the brightness, then they switch on and also the switch off. Okay, now we're going to see the part. Okay, first one, we need to know characteristic first for LDR. Excuse me. So this one, we call it as a light dependent resistor. Okay, LDR. That's a type of the resistor. So you can see here. This one is a LDR, the symbol. So where I put the LDR, I put at the base. Okay, when you put different location, they got different result. So I put at the base. So is resistance change with the intensity of the light. So this one resistor, they will change by the light intensity. So you can see the LDR value is high. Okay, when the light intensity is low and vice versa. Means when during the dark, resistance is high. Okay, when during the day, terbalik is it? Okay, excuse me. So LDR value is high when the light is dark. Yeah, correct. So during the dark, during the night lah. Okay, the LDR resistance is high. So during the day, what happened? During the day, that means morning, then you can find it. The LDR resistance automatic, the change become low. Okay, so this one is a characteristic for the LDR. So when we know the characteristic, now we need to bring the LDR, bring the whole circuit, go to morning and go to the night. We see what happened. Okay, so you can see the diagram here. This one is a LDR lah. This one is the component of the LDR. So this one is a symbol of the LDR. So LDR, what's the function? LDR, actually the function, they want to light up the bulb in the dark environment and also turn off during the daylight. Okay, you want to opposite the function also can. Maybe the day you want to turn on, maybe the night you want to turn off, also can. Okay, important, the function is you control the switch. You make the switch automatic, they will on. Okay, this one is a function for these situations. Okay, now we go through during the night, what happened first? Okay, now I put the LDR at the bottom. This one's a base circuit. Okay, now first one, in the dark, during the dark, LDR resistance is very high. Agree? When the LDR resistance very high, what happened? The voltage increasing. Voltage across the LDR increase. So when voltage increase, now you see LDR voltage more than minimum BE, means that more than junction voltage. When it's just more than junction voltage, understood, base current will flow to turn on transistor. Then the rest you understood already lah. You can explain by yourself. When it just on transistor, what happened? This condition, they cause high collector current to flow. Finally, the bulb light up. So that means during the night, that means the day you see suddenly the sky become dark already. They want to raining, heavy raining. So the sky become dark, automatic, the switch will turn on the light. Okay, so that means during the day, what happened? Okay, if I put the LDR at the bottom, during the day, what happened? Okay, we need to explain later. You see what happened? So from here, as the LDR is connected at the base circuit, transistor will turn on during the dark condition. Okay, remember, this one is important. When the question just come out, the question like this one, they put the LDR up and also down, you must know the situation, what happened. So when they just put at the base, understood, they will on during the night time. Okay, so we go through another situation. Okay, during the bright condition means during the morning. Okay, under the bright condition, resistance of LDR is low. Okay, this is a characteristic. They become low. So voltage how? Voltage decreases. Okay, when the voltage just decreases, that means they're smaller than the junction voltage. Smaller junction voltage means no base current. If no base current, transistor off, transistor cannot on, off already. If no base current, what happened for collector? No collector current to flow, then the bulb turn off. So the bulb cannot function now. Okay, during the day, they will off one. So from here, the conclusion is, excuse me, as the LDR, you connected at the base circuit, transistor will turn off during the, terbalik already, I got to change, during the bright condition. Okay, not dark, terbalik already, this one. Okay, so from here, as the LDR just connected at the base circuit, transistor will turn off during the bright condition. That means morning lah. Okay, morning they will off. Okay, normally the question how they ask. Okay, example, the question like this. Okay, night they will on, morning cannot on. So they ask you, now I want terbalik. I want during morning, I want to on. Then at night, I want to off. What you need to do? So your answer is, you replace the LDR with the R. Change the LDR, go up. Bring the resistor come down. Then your situation already changed. Okay, so your situation will become morning, they will automatic on, then the night they will automatic off. Okay, not only for the light. Example, you can apply for the door also can. Okay, so you apply for the door during the morning. Okay, got workers to come the factory. They automatic will on. On means what? On the door, open the door. So they detect the light lah. Okay, during the day, morning already, they automatically open the door. So the workers can go in. Okay, during the night time, okay, they detect the surrounding become dark. Then the door automatic, they will off, close. So that means this one is a LDR function. So this one is depend the situation. Just tell you this one's one of the example for the LDR as a light control. Okay, so we go through to the another situations. So this one circuit we use in the automatic street light. Okay, the street light. Okay, so from here you got one of the small exercise to let you to understand what is the LDR. Okay, so from here you see the LDR at the top. LDR at the top. So from here they want to interchange the position with the resistor. Okay, now we're going to see first part. You see this one table. Okay, there's a during focus. Now at the top. Focus, there is now is a day. During morning. Okay, so morning resistor how? Okay, resistor for LDR how? So during the morning resistor must be low. Okay, resistor is low. So if you say the LDR become low resistance, so the voltage how? Voltage is understood also low because there's a directly proportional. So if this one become low voltage, what do you think about the bottom one? The bottom one must be high voltage because there's a voltage divider because they're sharing 6 volt. If I say the first one, LDR, they only got 0.2 volt, then the rest must go to the V2. Okay, so from here, what happened for the base voltage? Base voltage must more than 0.7. Okay, because they get full voltage already. So if you get full voltage, then you understood all the thing what happened. Then base current also will flow lor. Then got collector current, then transistor on, and the last one, the bulb light up. Okay, so this one is the what's the meaning for the during the daytime. What happened during the daytime? You find it, they can on. Okay, the light can be on. Why? Because I put the LDR at the top. So one thing to let you to easy to remember, when the LDR put at the top, the situation is abnormal. What means abnormal? During the day they on the light, or during the night they off the light. This one is called abnormal. Normally you during the night you on the light, is it? So this one, when you see the LDR at the top, there's an abnormal. Okay, we call it cacat. There's a cacat one. Okay, because they on the light during the morning, off the light during the night. Okay, so from here we go through another function for LDR. Okay, now is thermistor. Okay, transistor now join with the thermistor, become heat control switch. So they detect temperature. Okay, using the transistor, then put the thermistor to detect the temperature. So that means they're using the siren. That means when the temperature too high, then the siren is on. Then you see the light. So that means the fire is come ready. Okay, so you see how to function for this part. So this one is a thermistor, the component. This one is a symbol. Okay, now I put the thermistor at the top. Okay, at the top. So we see what happened. Okay, thermistor is a resistor. The function is resistance that changes with the surrounding temperature. So this one resistance that will change become temperature. We see the resistance high under low temperature. When there's a low temperature, automatically the resistance become very high. That means during the temperature high, suddenly the fire come already. This one resistance will drop. The resistance will drop. So we see what happened. Okay, as the surrounding the temperature increase, so the resistor become low. Okay, understood that resistor become low, and the voltage across the thermistor decreases. Okay, so we're going to see the diagram. Okay, temperature increase, resistor become low. Okay, this one resistor become low. Okay, what happened for the base? Voltage at the base increase. This one low resistor, this one become high voltage lah. Okay, when the voltage across the thermistor decreases, the voltage across the R increases. So when value VR, this one voltage R, more than PN junction, what happened? Base current flow lor. Then turn on transistor, then collector current also on. So finally, they can light up the bulb. You can put the bulb here. You also can put the siren here. So finally, the siren will be triggered on. So they detect, now the temperature is too high already. Maybe fire, maybe got smoke. So the siren on. Okay? So if I put the thermistor at the bottom, what happened? When I put at the bottom means what? Siren will on when the temperature low. When the temperature too low, the siren will be on. Okay, but normally we need the thermistor at the top because you want to make it when temperature high, then the siren can be on. Is it? So that means from here, the circuit is suitable as an automatic switch in a temperature control system. Okay, so for the LDR, when at the top, we assume that one is abnormal. Okay, when the thermistor at the top, we assume that one is a normal because temperature high, the alarm will be on. Okay, so this one is how you go to explain. When the question 4 marks, they just ask you, please explain how the siren can be on by using the concept transistor. Then you need to explain. Okay, or point by point also can. Okay, you've got 4 marks, that means at least you got 4 points to explain the proceeding. Okay, so you got one of the small exercise again. Okay, now I put the thermistor at the top. Thermistor at the top means normal lah. Okay, now the situation is low temperature. Low temperature. Okay, when low temperature, that means the resistance is high. Okay, resistance is high. Okay, thermistor voltage also high. They follow resistance. Okay, if the V1 is high, V2 automatic become low. Is it? So base voltage how? Base voltage now is less than 0.7. If less than 0.7, everything cannot function. So base current will not flow. Collector current also no flow. Last one, transistor off. Alarm go off. Okay, so this one is an explanation when I put the transistor, the thermistor at the top, but the situation is low temperature. So this one normal lah, is it? Low temperature, what you want to on the alarm, is it? So low temperature, we need to off the alarm. So during the high temperature, the automatic will on the alarm. Okay? Okay, so we got exercise. The student, you please respond me. Okay, we just left around 18 minutes. Okay, so from here you see the circuit. Okay, the diagram they show about the circuit transistor act as the automatic switch. Okay, this one is a R1. R1 is a 10 kilo ohm. Okay, after that, when the resistor P, okay, resistor P is a 50 kilo ohm. Calculate the potential difference across the P. Okay, so they want to find is a V2. Okay, info first. RP, 50 kilo ohm. Then V is a total, V is a 9. R1 is a 10K. Okay, they ask you what's a VP. Actually, we got two methods to find it. Okay, just now I told you you can find current. Okay, if you got enough information, you can find the current. If you want, you can using voltage divider. So I show you two methods. I show you the first one. Okay, first method, I find the current. So V equal IR, is it? So R1 plus RP, there's a total R. So 9 volt. Then I find what is the current. So I get the current first. Current is a 1.5 times 10 power negative 4 ampere. So after I find the current, I can find what is the VP. Because this one is a series. The current is the same one. So the current go to the P is the same. Also is 1.5 times 10 power negative 4. So I'm using the formula V equal IR. VP equal IRP. So 1.5 times 10 negative 4 multiply the RP. Okay, what's the RP? 50 kilo ohm. Okay, so I get the answer is how many? Okay, what is your answer? Can you give me? VP, what is the answer now? Okay, we're going to check. Any student can give the answer. Okay, anyone can be respond? What's the answer for voltage for the resistor P? Okay, anyone? Okay, just type in the chat room. That means I can see it. Nobody. Can find the VP just using the current. If the information enough lah. Okay, Jiao give me 7.5 volt. Okay, we go to check. Okay, we get it 7.5 volt. Okay, that's correct. Okay, many answer here. Kajing, Linghan also same. Okay, Alicia also same. Okay, then we using second method. Second method is a short one, but you need to using formula. Okay, let's see the second method. Okay, the second method, I just using formula. Okay, remember the formula. VP is a V2. So I take VP means RP lah. RP over, sorry, I think I missed one thing. Here must be multiply the V, multiply the V. So I just put in. Okay, you help me to change. Okay, this one, you need to multiply the V. If not, you cannot do the calculation. So multiply the V. Okay, so this one also same. Multiply the V. Multiply the V is how many? V is 9. So we multiply the 9. Okay, So from here, you can get the answer is the same one. So from here, okay, so Vp equal Rp over Rp plus R1, multiply the V. So from here, we just put in all the info. Okay, 60, because I take 10 plus 50 becomes 60 already. Then multiply the 9 volt. Final answer still the same, 7.5 volt. Okay, so this one simple more a bit lah. You need no need to do so many calculation like this. Okay, so from here we go through to the second question. Okay, let's see this one diagram. Okay, they show about the transistor circuit. They got one of the bulb automatically. So determine the potential difference across the point X to Z. X and Z. Can you tell me what is the potential difference? Okay, anybody can answer this one? Simply question, no calculation. Only pass the voltage from the X to Y, then to Z. Okay, how many volt? Okay, so if you understand this one question, actually you know the answer. Okay, the keyword is voltage divider. Okay, now they ask you X to Z, that means the whole bar, is it? They never say separate, the whole thing. Okay, how many voltage? Okay, anybody here can answer? For number 1. Okay, potential difference across the X and also the Z. Total is how many? Okay, anybody? If you don't know, you just refer the diagram. Diagram already got answer. Okay, no. Don't know. Okay, if don't know, I just write the answer lah. So the answer is a 6 volt. Because there's a voltage divider ma. Here is 6 volt. So another side also is a 6 volt. Yeah, Eric, that's correct. There's a 6 volt. Okay, voltage divider, they take whole voltage. If I ask you the X and also the Z, maybe you do know lah. Okay, if they ask about the Z until X, they will understood 6 volt. Okay, 6 volt lah. Okay, so from here we go to do the calculations. Okay, we need to calculation about the total resistance between the X and also the Z. Total resistance X and also the Z is how many? We just plus lah, because it's a series, is it? So the answer is how many? For the second question. Total resistance X and also Z. Okay, answer please. Okay, total resistance for X to Z. Okay, faster because we got still some question. This one question 2 only. Maybe got 4 or 5 question. Okay, what's your answer for number 2? Total resistance between the point X and also the point Z. Because they all provided. Okay, you can focus. I focus for you. You can see clear. This one's a 20K. This one is the 10K. Okay, so after that, you tell me total resistance is how many? Okay, 30 kilo ohm. Okay, Jaya give me 30 kilo ohm. So we just plus lah, is it? Simple only. So 30 kilo ohm. Okay, then we continue to the next part. Okay, calculate the current flow XZ. Current flow XZ. The whole current. Whole current. So I give you the tip is, just now you know the whole voltage. Then you find the whole resistance. Then can you find whole current or not? So this one is a tips. How to find the whole current. Okay, we're using the simple formula, V equal IR. Then you can find the whole current is how many. Okay, so we just wait the student to answer it. Whole current is how many? Okay, anybody here? We got Lena. Lena got on or not? The rest, Jerome, Adrian. I don't know here or not. Nixon, so long time already. Never appear. Okay, what's the answer for I? Voltage, you know, 6 volt. Total resistance, you also know, there's a 30K. So what is the current? Okay, anybody here? Okay, so we just waiting your answer. We just go to show what is that. Okay, calculations. Okay, V equal IR. If you want to find the I, V over the R. Okay, we got answer from Eric. Okay, Eric said there's a 2 times 10 power negative 4 ampere. Okay, we go to check. Yeah, exactly the answer. Okay, 2 times 10 power of negative 4. Okay, Zuhui also correct. Okay, after that, Khatija also correct. Okay, then we go through to the next. Okay, the student, you prepare. When I just mentioned number 3, then you prepare number 4. Then we come very fast. Okay, we go to the number 4. Calculate the potential difference across Y, Z. Across the Y, Z. Okay, if you get the current, then you know the resistance. That's easy to do already. You no need using the voltage divider also can. You straightforward using V equal IR. Okay, V R2 we don't know, is it? But the I we know already. I, there's how many? This one should be the answer. Then the R we also know. Then we find what is the V when I just go to the YZ. Okay, we're using V equal IR, the formula. Okay, anybody? Must be fast, huh? Okay, maybe the line problem. You just type already, but I cannot see. So I just wait for you. Okay, anybody here? Potential different when you just go to the YZ. Okay, you can using voltage divider, but more formula you need to calculate. Okay, Sikajin, give me the answer already. 2 volt, 2 volt. Eric also 2 volt. Okay, Zuhui also 2 volt. Okay, so V2 equal I, R2. So we just put in all the I is how many, R is how many. So the final answer is, okay, 2 volt. Okay, this one is the calculation for the switch. Okay, we go to the next part. Number 3. Okay, when the light is detected by the LDR, the resistor LDR is 100 ohm. Okay, we see the diagram first. Okay, main voltage 6 volt. Okay, this one is a R 3300. This one is a LDR. Okay, LDR at the top. So this one should be the cacat one. Okay, cacat one. Okay, so from here, we just got 2 info. Okay, add one more. The resistor LDR 100. Okay, resistor LDR is 100. So that means R1 100, R2 is 3300. Then we got total volt 6. Then no more. Finish. Okay, state the potential difference across Y, Z. Then understood lah. Same like just now. Okay, what is the answer for the first one? Potential difference across Y, Z. Okay, anyone? Simple question. Same like just now. Okay, the student, you ready for question number 2? When I ask number 1, because so many students here, is it? So you're ready for the question number 2. So when you just do question number 2 finish, then when I just ask, then you just type. Show me the answer. Okay, so potential difference across the YZ is how many? Okay. Then also you're ready for the calculate potential difference across the LDR. So this one you can using the formula for the potential divider. Okay, anyone here? Number 1, the answer for number 1. Okay, many students disappear already. Charan disappear. Hari also disappear. Lisa disappear. Sharon today not here. Okay. Esther also not reply. Okay, 6 vote. Okay, Eric Chu says 6 vote. So correct lah, because we just follow the original. Okay, the rest. Number 2. Have you do the calculation or not? Okay, number 2. Okay, number 2, they want to ask about V1. The potential difference across LDR, V1. So if I say V1, so I never mentioned V1 now, I just mentioned there's a PPC, follow the question. Okay, LDR, PPC, V equal to the, must be R1. If this one V1, this one must be R1. So I label PPC, so this one R also PPC lah. Over the RPPC plus R2, multiply total V. Okay, so from here, I apply all the thing in. VPPC, I don't know, but resistance, I know. There's 100. Okay, 100 ohm. Then the bottom one, there's 100 plus 3,300. Then multiply the total voltage. There's a 6. Okay, now your turn to tell me what's the answer for VPPC. That means the voltage for the LDR. Okay, how many voltage? Okay, your answer sure less than 6 lah, agree, because total is a 6 volt ma. You cannot more than 6 volt one. Okay, so we just left for the student to answer it. I think I still got question, so you must faster to answer it. Okay, Zihui, 0.1765 volt. So the answer, yeah, correct. 0.176 volt. Okay, so this one is the answer when you just apply the voltage divider. Okay, then we go to number 4. Number 4 some more. Okay, now, okay, Esther correct. When I just shout Esther, then Esther come out already. Okay, when I show about the temperature control alarm circuit, now the resistor R has the resistance 10K. This one, 10K. The potential difference across the XY. Where's the XY? This one XY. So we call it as a V2. V2 at least 5.5 volt. Okay, if you want to turn on the lamp, turn on the light lah. Okay, then what is the resistor of the thermistor when the bulb is light up? So they ask this one, RT is how many? So we write in 4. R2, 10K. Then the V2, 5.5. Okay, they say at least, so we just take 5.5 lah. Then overall, 6 volt. Okay, last one, 6 volt is here, 6 volt. So RT is how many? So we using voltage divider. Okay, voltage divider. So I want to find RT, is it? So you put VT lo. Okay, VT means there's a V2. Sorry, there's a V1. Okay, you can using V1, you can using V2. Why I using V2? Because they only got one RT. If I using V1, V1 means VT lah. If I using VT, equal RT over RT plus R2 means you got 2 RT. You got 2 RT, that means a little bit hard lah. You can do the simultaneous, they become hard a bit. Okay, so if I using V2, it's okay because all info is there already. Up to you lah. Okay, if you want to do the V1 also can, depend for yours. So remember, if you're using V1, this one must be R1 lah. Okay, so from here I'm using V2, so this one is R2. Okay, so from here RT is stand for R1 for these situations. So I just put in all the things. V2 I get it 5.5. R2 is how many? R2 is the bottom one, 10K. Then RT, I don't know. Then I put 10K plus RT, multiply total volt. There's a 6 volt. Okay, I want to find RT. So I just multiply. 5.5, this one I bring to 5.5. So this one is a 10K plus RT. Then equals 6 multiply with 10K. So becomes 60K, 60K already. So this one 5.5 I just put in. 5.5 I put in. Then I want to find RT. So anyone give me the answer for resistance of thermistor now? Okay, resistor of thermistor is how many? Okay, we still got 5 minutes, huh? Okay, we just wait the student to answer. Many of you also never answer me. Example, the Lena don't know go where already. Lena, where are you? Some more disappear. Danish also do not go where. Okay, please answer. What's the answer for RT? Okay, RT. Okay, Mei Ling can answer or not? Tuition. Tuition. Okay, Nixon. Nixon, this one is which one question? This one's the last question, is it? Ayo, Nixon, don't simply see the answer, then you just copy. I want this answer. Is it that this answer is 0.1765? This was the last one. Okay, the rest. Ayo, internet slow lah. Or you just on the camera, or you just on the internet, or on the video. Okay, Zihui give me 909.1 ohm. Okay. Okay, Zixuan also give me. Okay, Esther also give me the answer. Okay, we just put in. So finally, I want to find the RT. RT is a 909.1 ohm. Okay, that's the answer. Okay, Nixon wrong already. Don't copy the answer. Okay, so I think this one should be the last one. Okay, today what you need to do. Okay, you help me to finish your formative practice 5.3. Copy the question and answer it. Okay, the second one, you need to fill in your Google form. Okay, your Google form as today, attendance, and also your PBD marks. Inside got 10 questions about the transistor. Okay, so today got lesson code. The lesson code is a 5S2. 5S2 capital letter underscore 2021. Okay, so anybody here can help me to type 5S2. Okay, you just type 5S2 capital letter your class 5S2. Okay, then underscore 2021. 5. Okay, I'm going to type here. I slow a bit 5S2 underscore under 5 underscore. Where's the underscore? Okay, you help me to find it. Yeah, correct. Mailing type already. 5S2 underscore. Then after that, there is a 2021. Lina also type already. Okay, 5S2 underscore 2021. That's a today lesson code. Okay, so our lesson just until here. Okay, Google Form. So from here, we finish the lesson. Okay, so hopefully the student, you understand what I'm teaching today. If you don't know, that means you just PM me about the exercise or anything about the topics. Okay, so have a nice day. Thank you for your watching. Okay, bye everyone.